Good afternoon, this is Schweitzer, and we're looking to go over some answers to the practice test. This is stuff that we would want to be able to do relatively routinely. And grab a thinner pen. Alright, let's move along quickly here. Okay, so aluminum acetate plus metal. First thing you should recognize, to be able to flip these over, this is Al acetate C2H3O2 parentheses 3 plus sodium metal yields. Now this is a oxidation reduction reaction. We have you should be recognizing that template as being sort of an ionic compound XY plus a single element with no charge. So metals will exchange with metals, nonmetals with nonmetals. So this is the cation, this is an anion, and typically this thing here is aqueous. This is now no charge. So the potential products will be sodium metal, sodium ion. So this would be sodium acetate C2H3O2. This is a +1, and this is still a -1. And then the aluminum metal is now at no charge. Alright, so again, we want to balance this reaction, so you can just balance if you want, be a 3 here and a 3 here. Hopefully you're seeing some of the half reactions. It doesn't say to, for that, but we do need to give to see if it's going to run, we need to give the net voltage. And if you're getting better at this, you can just maybe do something like this, where what's the voltage of this guy and what's the voltage of this guy. Alright, so in this case I'll do a little bit side here. Al plus 3 goes to Al metal. This is going to be reduction, 3 electrons, and then we have sodium metal going to sodium ion, and this is going to be +1 electron. That's oxidation. Alright, my two voltages. I'm going to flip over to my voltage chart, and I'm looking for the reduction of aluminum. That should be right on there, and it will be right here, -1.66. This is -1.66. Sodium metal oxidized, so sodium metal is located here. Now that one's got to get flipped because this is a reduction. Positive 2.71, positive 2.71, and of course you can add those together and you're going to get a positive voltage, and therefore yes, it will run. Alright, next one, cobalt 2 sulfide, so COS. This is a +2 -2 plus nickel, and then chloride, nickel 2 chloride. Chloride's a -1 charge, so only a 2 right here. This is +2 -1. I always encourage people to write the charges above them. This is a solubility reaction, so this cation will have an opportunity to go with the chloride. Cobalt chloride, cobalt chloride, yeah, and still +2 -1 plus nickel sulfide. Nickel sulfide. This is a +2 -2 right there. Now we need to check solubilities on these guys, and I'm not going to go through here how to check the solubilities. This guy will be, I do believe, aqueous, and this guy will be solid. If they're both aqueous, then this would be a no reaction. Alright, next one, chugging along here. Ammonium silicate. Alright, so NH4SiO3, and this would be a 2 charge, so we have to have a 2 here, and then we have plus potassium phosphate, PO4 right there. And again, note this template. This is a 2 ionic compounds reacting with one another. So this is a classic solubility reaction. So we have, in this case, K SiO3, and because of charges it would be a 2 here, plus 1 minus 2, and we have ammonium NH4PO4. Now again here we'll put parentheses and there'll be a 3 here. When we do our solubilities in both of these guys, of course we're checking our solubility charts, but we have a little bit of a quick check here, which is potassium, ammonium, and nitrate, right? Sodium. These guys are always soluble, so this one will be AQ, and because of the potassium, and this is going to be AQ because of the ammonium, very soluble. So even though we dumped them into a beaker together and we wrote it on paper, doesn't mean it actually is going to anything's going to happen. So this guy is a no reaction. All right, sodium metal plus chlorine gas, Na plus chlorine gas, Cl. Don't forget a 2 here. This is just going to be a composition or this reaction. Put the two together, forming an ionic compound, Na and Cl. This actually is a redox reaction. That's actually the type of reaction. Notice we have 0 and 0 plus 1 minus 1. So the charges are changing, so this is a redox reaction. This guy is losing electrons, this guy is gaining electrons. So balancing wise, we could just put a 2 here and a 2 here. Alright, moving along. This is an example number 5 of just a decomposition reaction. So in this case, we don't know necessarily what something is going to decompose to. Would need to be tested in the lab, but either way, we give you the whole thing. So this is simply a translate. I'm not going to give the answer for this one, just translating these words is all we're looking for, and balancing. Alright, magnesium, metal, and sulfuric acid. Okay, so we got magnesium, metal, no charge, plus an acid, which is looks very similar to an ionic compound with H2SO4. I would make a note as well on previous tests over the last couple of years. This translating an acid into a word is a place where people lost points. So it's new to this chapter, and you got to make sure you're proficient in it. All right, so metals, and we have exchanging with, well, there's no this hydrogen is going to be our metal. So it's a plus 1 minus 2. You'll look on your chart for exchanging, and you'll find that hydrogen, it can easily convert into hydrogen gas, and then the magnesium will become the ion, or exchanging charge, and the sulfate is the spectator. This is a plus 2 minus 1. All right, half reactions. I'll put it up here. We have magnesium going to Mg2 plus 2 electrons, and then we have H plus goes to H2, and this is of course would be 2 of these guys right off the bat, and I would need 2 electrons on this side. Okay, each of these has a voltage, and let's get the voltages. All right, now this is a relative system here, so you'll note that on this thing that hydrogen actually right here is 0. All right, it is 0. Doesn't matter which way you flip it. Okay, the reduction here is 0, so the oxidation is also 0. So this guy is going to be voltage equals 0. All right, this one is oxidation. All right, and looking for magnesium here. Is it lower? So because it's oxidation, and because we're only showing reduction, we got to flip this one. This is a reduction version. We're going to flip it to a positive 2.37, and therefore the addition on this thing is pretty easy. Add together, and our net voltage is 2.37. And again, I typically sometimes I'll put up a smiley face just to show that it's going to run. That's a Schweitzer thing. It's not AP chemistry or anything like that thing. Just be aware, indicating that is a forward reaction going to run. All right, combustion reaction. Okay, again, we're getting the same products here. We have C2 H6 plus O2 yields carbon dioxide, CO2, plus H2O. Alright, and then we gotta balance this thing. So balancing, we go carbons first. This is the hardest one to balance, so we'll show an example. 3 of these guys. It gives me 6 hydrogens. Hydrogen second, oxygen last. I'd like to put a number right here on my oxygen just to balance it all up. 2 times 2 is 4, plus 3 more is 7. So I can't get 7 here, unless I did a fraction, which would be actually just fine. But I'm going to double everything. 2, 4, 6. Alright. 6 plus another 4 is 8. Plus 6 is 14, so we can get 7 right there. Alright, moving along here, number 8. We have chromium chloride, so CrCl2 plus gold sulfide, AuS. This is going to be 3, 2. I did that backwards. Alright, so 2S3. Alright, this is a solubility reaction. So we're going to do chromium sulfide. Alright, and plus 2 minus 2, charges are not changing, and it's not a redox reaction. And we have AuCl, and this would be a 3 here. Check solubilities, and you're ready to roll. I'll let you check those. Next one, a container is an aqueous solution poured into it, and reaction takes place causing a solid to be formed. Alright, we're dumping these two things together, it looks like. So it wants me to draw it out, I guess, here. So it's going to be barium chloride plus lead nitrate. And there we go. And we're going to get barium nitrate. And of course, this is a quick check, so this is going to be aqueous. I guess the question might be what forms a solid. In this case, has to be lead chloride, PbCl2. This would be a solid. Alright, that's the end of this particular page. Let's go to the next page. We have, alright, what type of a reaction is this? Okay, I guess that's off the previous page. That would be a solubility. Write out the molecular equation. That's on the previous page, which is located right there. On the bottom here. I'm going to rewrite it. Come on. Alright, come on. There we go. There it is. Lead nitrate and barium chloride. Alright, so at that point, let's flip over here. And my ionic equation, we'll do that one here, is things that are dissolved, it actually holds apart. Barium plus Cl negative plus Pb plus 2 plus NO3 minus 1 yields lead chloride plus barium. Now, in this case, still going to be plus soluble, and the nitrate still will be soluble. NO3 minus 1. This is together, meaning that it is a solid. The net ion equation is going to be just the lead ion, Pb2 plus the Cl minus yields lead chloride. This one typically also has you balance it, which would be really simple. So just go ahead and do that. Alright, next one, we want to draw this out. Okay, Ba plus 2, and you'd want to draw it proportional if you can. Okay, and this is going to be PB 2 plus, get that a little closer, PB 2 plus. I'm going to put, well, let's just make this guy a negative, so I'll make a little legend here, negative and negative, and I'm going to write out nitrate. Alright, so my spectators, I have 2 nitrates, put those over here, and then I have the barium will go here, and then Ba plus 2, that's still going to be there. And you can draw more than if you want, but then make sure you're proportional. I have 1 lead and Pb, and then Cl2 goes in the bottom. It's a solid. Make sure you get that as solid. Alright, next up here, we have ourselves another little scenario, solid chunk of aluminum is placed in zinc nitrate. So it should be a solution of zinc nitrate, aqueous, not solid, so it's going to be, what type of reaction is well, we have simple aluminum. Let's write out the reaction. Aluminum plus zinc nitrate, parentheses, 2, goes to zinc. Now zinc is its own single metal, no charge, plus aluminum, and then it would be NO3, 3. Alright, now again, just because it's written together doesn't mean they're actually together. So the ionic equation is going to be aluminum metal, aluminum solid, plus zinc 2 plus NO3 minus goes to zinc metal, and then plus Al plus 3 plus NO3 minus. Alright. Alright, so the net equation is going to be aluminum metal plus zinc 2 plus yields, okay, and then we have zinc metal, should be 0 there, alright, plus aluminum plus 3. Now we got to balance this thing, and to do the balancing I'm going to write out the half reactions. We have aluminum, and we'll check the voltages. Aluminum going to Al plus 3, and I have 3 electrons here, and then I have zinc 2 plus going to zinc metal plus 2 electrons. This is reduction, so this will be right on my chart. This is oxidation, that one's going to be flipped. So as we go back here, we'll find this zinc one is located right here, negative 0.76. So that's not pushing in a spontaneous direction. I'll sit with the aluminum's at. Let's see. There's aluminum right here. Now that's reduction. I got to flip it for the oxidation, and that's a positive 1.66 volts. All right, so we have a positive, looks like 0.9 volts, and it will run. All right, so I just answered the next question, and then we'll draw a picture out, and then we'll be all done. Okay. Determine the voltage of this process. Is it spontaneous? How do you know? All right, the voltage is the 0.9 volts. Is it spontaneous? Yes, because this is positive. Okay. Model the process before and after. Okay, so let's draw this out here, and be very careful how you draw it so you can clearly figure out what it is. Let's draw one cycle of this thing. So when I balance it, I didn't balance it up. Let's go balance this thing quickly. Okay, so you want your electrons to be balanced. I got 3 electrons here. I want 2 electrons here, so I want them both to be the same. So whatever's lost is gained. This is going to go times 3, and this is going to go times 2. That's 2, 2, 6, 6, 2, that's right, 3, and 3. So I'm going to have 2 aluminums and 3 zincs taking part in this process. So I have 2 aluminums, a little more room. Okay, so I have 2 aluminums going to jump off and 3 zincs in the solutions before. Zinc 2 plus, zinc 2 plus, zinc 2 plus. Afterwards, I have an aluminum plus 3, and aluminum plus, that's in solution, and I could put my 3 zincs on here if you'd like. And I think that's fine. That's pretty easy to see right there. And that ends our process today. Thank you very much.